Imagine a cable reaching the stars. Every rocket launch burns $5 million in fuel, and most rockets become scrap metal immediately. It's time to change the rules.
What if you could just take an elevator straight to space? We are actually building it.
The Obayashi Corporation is betting on this mega project. Target date: an equatorial floating port, an orbiting counterweight, and a super strong cable. No explosive fuel, fully electric, clean and 100% reusable.
The key is carbon nanotubes, the only super material strong enough to carry the structure.
Shizuoka University is pushing this material to its limits. They send it straight to the ISS for testing. And here is how we will turn theory into a massive, real-world construction site. Everything starts on the ground. 40mm steel plates are plasma cut with absolute precision. They are bent to the perfect radius, forming a 400-meter floating ring. A tiny leak means sinking. Every piece must align with sub-millimeter precision. Beneath the surface, divers seal the joints, battling salt and immense pressure. Inside, steel ring frames are reinforced every 2 meters. The hull must never deform.
48,000 tons of ballast concrete are poured into the base to prevent the port from capsizing in storms.
This structure is like a surface submarine, designed to withstand equatorial typhoons for a century.
The top deck is sealed. Prefabricated steel sections are lowered with sub-millimeter accuracy. The ballast water piping runs along the hull. Every single valve is torqued manually. This will be the tallest object on Earth. Lightning strikes will be relentless. Solid copper grounds the deck.
The mooring chains alone weigh 6,000 tons, forged from ultra-high-strength alloy steel.
The steel core is complete. The colossal port finally leaves the dry dock for open waters.
A 60-meter central tower rises from the core, constructed with a complex spatial steel grid. Dynamic power cables are routed through every pillar. One mistake means a total blackout. Sensors are attached everywhere. If the cable vibrates even slightly, the system registers it instantly. Charging stations and guide rails are welded directly to the deck, supporting machines weighing hundreds of tons.
This entire megastructure exists for one singular purpose: to catch the cable dropping from orbit and never let go.
This is a miniature city. Water desalination, generators, and waste treatment run continuously. 6 backup diesel generators are dropped into the vault. This port cannot afford to lose power. High-energy laser dishes. They will beam wireless power up to charge the climbers. A heavy rubber membrane seals the base, stopping massive ocean waves from flooding the cable slot. The helipad sits on the edge, the only escape route, or for routine crew rotations. The heart of the system, the control room, lined with screens, operating 24/7. Safety locks clamp to the ceiling rails. No matter the storm, the crew won't be blown away. Arrived at the equator, 12 thrusters blast to maintain balance. The anchor chains are pulled taut. This is where the engineering marvel begins. CVD reactors grow carbon nanotubes, atom by atom. The ribbons are twisted into fibers. Thousands of strands woven to share the load. A molten polymer matrix is compressed, forming a solid, ultra-stiff ribbon.
Adding a radiation shield. Without it, space storms would roast the carbon structure.
Every inch is scanned. A single micro crack, and the entire system snaps.
This is the seed cable, 96,000 kilometers long, weighing less than a truck, but holding more than a skyscraper.
The seed is wound onto special aluminum cores with perfect tension. One slip, and it's ruined. Each spool is sealed in an inert gas canister. Oxygen destroys this material in space.
Arriving at the launch pad, unsealed, inspected, and ready to be loaded into the rocket.
The spool is locked into the orbital module. Mechanical clamps ensure a perfect release.
A magnetic brake system controls the speed when the cable freefalls toward Earth. The fairing closes. 20 tons of nanotube seed are ready to ride fire to orbit.
Final system test. Drives and tension sensors report all green.
Pumping 300 tons of liquid oxygen. Solid ice coats the hull.
Clear the pad. Ignition. The most ambitious journey in human history takes flight.
Destination: geostationary orbit, 36,000 kilometers up, where centrifugal force and gravity cancel out.
Orbit achieved. The seed module releases its shell.
Brakes release. The cable freefalls, plunging straight toward the port waiting 22,000 miles below. Electromagnetic brakes manage the fall. Too fast, and friction will burn it up in the atmosphere. Keep your eyes peeled. The delicate thread falling for days finally punches through the clouds. Aircraft close in, snagging the tail with a U-hook before the wind tears it away.
Touchdown. Technicians manually thread the ribbon into the tensioning drums. Winches engage. The cable pulls taut like a giant guitar string piercing the heavens.
Everything is locked. That delicate thread is now the greatest structure humanity has ever built.
A hydraulic anchor bites the tail. The pressure could crush boulders, but the nanocarbon is unharmed.
Salty sea air corrodes everything. The cable core is isolated inside a completely sealed chamber.
Storms will shake it like a hammock. Sensors read tension so the port can steer and prevent a snap. Tension is perfect. The route is open. Now we turn it into a high-speed freight line. The seed cable can only hold a few tons. An army of small climbing robots is mobilized.
Instead of wheels, they use linear magnetic clamps, gripping the ribbon with zero friction.
Every roller touching the cable must be perfectly smooth. A tiny burr could tear the nanofibers.
The machine carries its own solar panels to catch laser beams from the port, eliminating heavy batteries.
Wrapped in thermal foil to deflect radiation, surviving deep freezes and blistering solar heat.
Each climber carries a secondary ribbon spool, pasting a new layer to thicken the main cable as it ascends.
Emergency jaws lock onto the cable, gripping 100 tons to prevent a catastrophic fall during power loss.
Power on. The motors hum, awaiting commands. Every sensor flashes green. Approved.
Heading out to sea. A grueling 3-week voyage brings the first climber to the port.
Entering the starting slot. The jaws open wide and swallow the ribbon into its core.
Laser power engaged. Motors spin up, and the giant machine begins its ascent to the heavens.
As it climbs, it unspools a fresh ribbon, pasting it flat to double the cable's strength.
Every bond is scanned. A glue misalignment? The robot halts, reverses, and repastes the section.
Piercing the deadly Van Allen radiation belts, the first climber docks at GEO, after 8 grueling days.
Robots descend for maintenance. Burned rollers are swapped, reloaded, and sent right back up.
Space debris incoming. The port fires thrusters, shifting the cable to dodge a fatal collision.
Storm passes. A mini inspection robot zips up, using ultrasound to scan for microfractures. Lightning blew the copper ground. It sacrificed itself for the tower. Crews replace it instantly.
Multiplication. 100 climbers ascend continuously. The cable bulks up, 100 times thicker than before.
Exhausted climbers become deadweight at the peak, forming a massive counterweight to hold the tension. Year 6. The factory weaves ultra-thick carbon mesh, strong enough to haul shipping containers.
Deploying Generation 2 climbers, big enough to haul heavy cargo. Big fish need bigger jaws. Final reinforcement. The thick tape is melted and fused into a single, indestructible nanocarbon pillar.
100 tons of dead weight. If the cable snaps, the backlash will obliterate the entire port.
While the cable matures, GEO station modules are hurled into orbit to form the core skeleton.
A robotic arm grabs the new module, slamming it into the hub like a giant, high-stakes puzzle. A centrifuge ring. Muscles atrophy in 0G, but this spinning ring simulates Earth's gravity forever. A giant slip ring guides the cable. If it rubs against the station, the structure tears apart.
The solar sails unfurl. The station awakens, drawing limitless power, never to be unplugged.
Station complete. Cable secured. The final piece. A passenger cabin flung into the sky.
The first space train boards 8 humans, carving a path through the stormy sky.
Food, water, and oxygen packed tight. Enough for 8 days of survival in case they get stuck.
Final cross-check. Throw the switch. Life and death now ride purely on this nanocarbon ribbon.
Liftoff. Forget rockets. This space train rips through the sky, rewriting the laws of gravity. Maximum tension. Heart rates, pressure, altitude. Watched flawlessly during this intense 8-day vertical climb.
The counterweight station must grow. Deadweight keeps the cable taut like a drawn bow.
The peak bulges into a colossal junk pile, anchoring the entire 96,000-kilometer highway. Upgrading to business class. A flying hotel with leather seats makes the journey a resort experience.
Prepping supplies. 8 days dangling on a wire requires a tightly packed survival cache. Checking every gear. A single millimeter gap is rejected. Safety is the absolute law.
Final checklist. Green lights. Hearts pound as the launch sequence engages.
Lift off. The space bus rips through the clouds, leaving the stormy world behind.
Destination reached. GEO catches the exhausted travelers after an 8-day vertical journey. The 1,000-star hotel is open. Humanity's wildest dream is now a tangible reality. $10 a kilogram. Dirt cheap. The billion-dollar rocket industry is obsolete overnight.
One cable isn't enough. Construction on Port 2 begins immediately, moving at breakneck speed.
A floating city emerges in orbit. The peak becomes a colossal, sprawling construction site.
The highway is fully operational. 5 lanes of traffic climbing at breakneck speed, tearing through the clouds. And this magnificent dream, once mocked as insane, ridiculous, and delusional science fiction, now stands firmly on the salty equatorial sea, a testament to relentless, unrivaled human ingenuity.
Japan dreamed it, and now they have touched the stars, lighting the way to our future.
Subscribe to the channel for more projects that shatter the laws of nature, defying every barrier.